Hello and welcome to the AI Engineering Podcast, your guide to the fast-moving world of building scalable and maintainable AI systems. When ML teams try to run complex workflows through traditional orchestration tools, they hit walls. Cash App discovered this with their fraud detection models. They needed flexible compute, isolated environments, and seamless data exchange between workflows, but their existing tools couldn't deliver. That's why Cash App relies on Prefect. Now their ML workflows run on whatever infrastructure each model needs across Google Cloud, AWS, and Databricks. Custom packages stay isolated. Model outputs flow seamlessly between workflows. Companies like Whoop and 1Password also trust Prefect for their critical workflows, but Prefect didn't stop there. They just launched FastMCP, production-ready infrastructure for AI tools. You get Prefect's orchestration plus instant OAuth, serverless scaling, and blazing fast Python execution. Deploy your AI tools once, connect to Claude, Cursor, or any MCP client. No more building auth flows or managing servers. Prefect orchestrates your ML pipeline. FastMCP handles your AI tool infrastructure. See what Prefect and FastMCP can do for your AI workflows at aiengineeringpodcast.com/prefect today. Your host is Tobias Macy, and today I'm interviewing Brijesh Tripathi about Flex AI, a platform offering a service-oriented abstraction for AI workloads. So Brijesh, can you start by introducing yourself?
Yeah, hi. My name is Brijesh Tripathi. I'm the CEO of Flex AI. I grew up in India, did my undergrad at IIT Kanpur and then moved to US and did my master's at Stanford. And from there on, I've been lucky to be part of some of the most amazing companies in the Bay Area. I worked at NVIDIA, Apple, Tesla, and Intel. And what I realized during my career is that I really enjoy bringing people and technologies together. And I really like solving tough problems. So a couple of years ago, I was working on an interesting project, which was one of the biggest, largest supercomputer of the world at that time, Aurora, that was handed over to Argonne National Lab. I realized that there is something that is missing in the current offerings at the infrastructure level, and that is the ease of access. We got the systems installed, and it took us a very long time to get that handed over to some of our developers, scientists who were actually solving real world problems like climate change and medicine research. And from there, I got the idea that there is a layer missing in the infrastructure management that simplifies access to compute. So that's what Flex AI is all about.
And do you remember how you first got started working in the ML and AI space?
Yeah, I think it's a long story again, but it goes all the way back to really dealing with the complexities of AI. But before that, I was assigned a role of chief architect for AI and HPC architecture at Intel. The first task I had was to figure out what is the right architecture for AI and ML workloads. And I observed that a lot of the new architectures that are coming out now had one deficiency, and that was they all focused on the highest performance, yet they were all becoming very inefficient. And while I was trying to figure all of that out, I was also realizing that we build this massive amount of infrastructure, and a lot of that actually sits idle. So to combine the two things, I realized that I think we need to change the fundamental architecture of how we design these things and focus on efficiency, energy efficiency, and then change the way we deliver these compute to our end users. And that led to an infrastructure platform management layer, which is what we are building at Flex AI.
And so digging a bit more into Flex AI and what you're offering, I'm also interested in some of the ways that you're seeing those infrastructure challenges contribute to the friction that's involved in developing and operating these very compute-heavy AI applications that have become very popular and prolific over the past couple of years.
The ChatGPT era basically changed a lot of the thought process on how small teams can actually be massively powerful and very efficient. So now you're starting to see one or two people companies that are actually building real good products, solving real problems. They actually are onto something. They have access to powerful models, dealing with very smart people, and they have this urgency to move fast. So they iterate fast, they want to iterate fast. But the challenge is that they all run into setting up infrastructure, maintaining infrastructure, and dealing with failures that happen left and right. So instead of solving real problems, these teams actually then become DevOps experts and start dealing with infrastructure. That is slowing them down. And that's actually one of the challenges that we are trying to solve here. Now, the other thing that's actually also interesting is when you're dealing with the current infrastructure and your access is through renting GPUs from either hyperscalers or these large, neo clouds like CoreWeave, you have to now deal with unpredictable cost. And if you're trying to solve a problem that requires you to have a GPU for, let's say, a few hours, but there is no access for a few hours for a GPU, you have to now go block it for a week or a month. And that literally spikes the bill, that raises the bill to a point where you can run out of money while just renting GPUs before you even finish building what you're building. And finally, as people rent GPUs, they go and use infrastructure. Different places will end up requiring different setup. So if you go get compute from Azure, it will have a very different setup. If you get it from Amazon, it will be a very different setup. Google, same thing. And then these neoclouds will offer very different settings like virtual machines or bare metal. All of that requires these very small teams who are actually not infrastructure experts to now have to go build the infrastructure layer on top of what they're getting. That takes a toll on these people. They basically are spending less time building and solving their real problems, but they end up spending a lot of time just maintaining and managing these infrastructures. So, as a founder, I actually feel for them. And, I want to have a very small team, a scrappy team, and I empathize with these people. So sometimes when I deal with these small groups of people, small teams, small startups, and they realize the value of what FlexAI is doing for them, that makes my heart happy. So I'm really excited about helping some of these founders, my peers, who are trying to solve some real problems, get rid of the infrastructure problem they face every day.
Particularly with a focus on those founders and projects that are in the early stages of proof of concept or trying to figure out the appropriate product market fit. What are some of the ways that friction and the cost unpredictability at the infrastructure level can prevent them from being able to scale at the pace that they would otherwise be able to if that cost was not a factor?
Yeah, I mean, iteration loop, the number of times you can actually go experiment with your model, improve your model, that's the key there. And if you're dealing with the infrastructure challenges, that means you're not iterating fast enough. That slows you down. If you slow down, that means that someone else can catch up and actually do something better than you. So losing your edge by just reducing the number of iterations or making the loop longer is how they are struggling. And one of the things that FlexAI does is it takes the friction away from these startups. You are just focused on your model iteration or your application iteration or your agent iteration. And rest of it is taken care of by FlexAI. And that means you're going much faster than what you would do without us.
And to be a little bit hyperbolic on the infrastructure piece, isn't that what Kubernetes was supposed to solve for us? You could just write your code and deploy it into Kubernetes, and it would run everywhere that you had a Kubernetes cluster, right?
So that's ideally true if it actually worked. Theoretically, that was the promise made. But unfortunately, the dependencies, the libraries, the overall complexity of actually starting from n number of Kubernetes implementation. Not everybody offers the exact same abstraction. It just doesn't work the way we expect, people expect it. And in fact, that is actually one of the premises we have, which is we start from a Kubernetes layer that is now consistent. So our developers don't have to deal with the differences and the complexities of missing libraries or missing dependencies. It just works. But fundamentally, you're right. It was supposed to solve all of this. It doesn't. In fact, one of the things that we are doing, Tobias, is we're in near future, we are going to offer our customers an ability to bring their own containers. And those containers are then okay to run on multiple places. That becomes a way for us to handle custom flows and flows that are not currently supported by our platform. However, it still requires a very stable underlying management layer, underlying orchestration layer, so we can get better utilization. if you get Kubernetes to work, it doesn't mean that you are now accessing resources that are dedicated to you. It means that you have to carve out those things out. And that means there's still dealing with a bunch of idle cycles and wasted resources.
One of the aspects of running, in particular, these very compute heavy and GPU heavy workloads on a Kubernetes environment is that with CPUs, as long as they're the same architecture, it doesn't matter if you're running Intel or AMD. But if you are then in the GPU space and you're running between an NVIDIA GPU or an AMD GPU or a tensor processing unit, you need to have different drivers in place, which then also brings in questions around the software support in the code that you're writing, whether you're using CUDA or RockM or some other library that is able to take advantage of that compute accelerator. And that also brings in another layer of complexity and maintenance and management at the software level that is directly tied to the underlying hardware that you're working against. And I'm wondering how you're seeing teams address some of that complexity and some of the ways that you're thinking about that problem, and maybe offering some sort of, hardware software abstraction layer to be able to paper over some of those. And then also that brings up the question of potential loss of efficiency when you do have that translation layer, because you don't have just a direct throughput to the underlying hardware because you have to do that translation.
Yeah. Otherwise, that's an amazing, by the way, that's a very long question. So the answer is going to be long. But that's really the crux of what holds back a lot of alternates compared to what NVIDIA has to offer. So, if you are writing a model, a lot of times you will end up having very explicit CUDA calls in there that now go target a specific NVIDIA architecture. And in fact, the way it is implemented, if you're running on A100 and you move to H100, there is no automatic gains that come from a new architecture, even on NVIDIA. So it's so specific to a specific hardware model number that, ignoring some small updates every generation requires a bunch of rewrite and a bunch of rework of the models, just within the same architecture. So NVIDIA and AMD definitely doesn't work the same way. You have to deal with RockM versus CUDA. What we are trying to do is actually take away that complexity from developers. And the market is actually kind of helping in that sense. We're focusing on PyTorch. So PyTorch is an abstraction layer above CUDA, where a lot, you've seen a Triton layer being introduced in the PyTorch world, which is trying to create a unified model or programming model for multiple GPUs, and both AMD and NVIDIA are supported in there. But at our level, we are actually staying with CUDA on NVIDIA, but we have a code analyzer that will look at what your CUDA calls are and suggest replacing it with a more universal code that can also then go run on AMD. In some cases, we will even offer our developers, our customers, support to port their code to different architectures. Now, these are things that are quite relevant for training. And, as the market is moving more towards inference, we have made a decision that all of our training currently runs on NVIDIA. And so we focus on NVIDIA only with training. However, as we move towards inference, we are moving away from specific architecture optimization, and most of these inference solutions endpoints are being called with a standard OpenAI's API. Once we go into that level of abstraction, the implementation details per architecture is actually controlled by us. The developer or the user doesn't have to know which architecture it's going to run on, as long as we deliver the same API and the same results. And that's helping a lot. In the next couple of years, we believe that a pretty big majority of AI workloads is going to be inference. And hence, we are seeing a lot more multiple architectures being at play here. In fact, we are already now deploying AMD for inference and Tenstorrent for inference. And in future, we are also considering looking at Trainium and a couple of other new architectures for delivering inference.
The workload distribution was the next thing I was going to ask about, and you preempted my question a little by stating that you're focusing on inference. But to your point, inference is not the entirety of AI, it's just the thing that is gaining all of the attention right now. And so obviously the serving of a given model, whether that's a generative AI model that's focused on language outputs or a generative model that's focused on vision outputs, that has a certain architecture, although even that is in flux right now. But regardless of whether it's a generative model or a predictive model that's using something like a random forest or an XGBoost, the training time compared to the serving time are going to be orders of magnitude difference. And so I'm curious how you think about that aspect of the platform that you're offering in terms of being able to optimize for training time and iteration speed for being able to manage the experimentation loop, and then the deployment and serving of those models, where even if you are using a foundation model off the shelf, there are often cases where you want to be able to do some sort of post training and fine tuning of that model before you actually start serving it. And so I'm just wondering if you could talk to some of the ways that you're thinking about the overall AI lifecycle, as well as the expansion beyond the transformer attention based large language models that have gained all the popularity, and especially as we start to look into things like diffusion based models and Mamba architectures, et cetera.
Yeah, that's again a really good relevant question for the time, Wes. A couple of things to start with. Number one, I believe that the world is going to be a heterogeneous compute world in the future instead of a homogeneous single architecture. And the way maybe it's a simplifying thing for myself and our implementation right now, but the way I think about this is every stage of this development, starting from training to fine tuning to implementing a deployment model, whether it's a RAG thing or some other ways of MCP. Every stage is going to need or benefit from having somewhat customized and specialized architecture. And to us, to Flex AI, our offering is going to make sure that the workflow doesn't really have to fundamentally change because we are switching which architecture is being at which stage. So what we are doing right now is for pre-training and training, and in fact, even fine-tuning for at some level, depending on what the size of the cluster that we need to put there in, is we focus on NVIDIA because a lot of these models have been developed and are being developed with NVIDIA. So it's literally just simply too hard to actually start porting all of those models and giving a new architecture multiple years of time to develop and optimize and become competitive compared to what NVIDIA has to offer. So we kind of just say, to simplify the world, we have multiple things that we do on the pre-training and training side that still improve access and quality of training. We take care of failures automatically. We call it self-healing. We take care of replacements automatically. So if one node fails, we basically automatically replace it with another. We take care of scale. We take care of checkpointing, seamless checkpointing in the background without having to worry about wasting cycles. All of those things are actually already optimizing the runtime or the quality of the model and the iteration cycles that are being developed. But as we move towards the deployment and serving these models, we start getting into multiple architectures and multiple options, which we believe some of them are better than what if we stayed with just one architecture or one company are possible. So we just take a look at every stage of the problem, every stage of the workflow, and pick the right answer for the right workload. And the end result is that you get the best of all worlds, not just two worlds. We are even able to put ASICs in there for certain use cases. So there are some customers who are looking for edge deployment, and the cost will not allow them to put this on NVIDIA or AMD. On the other hand, if you are deploying it on edge, the performance and the power is actually so limiting that you have to now serve it on a much smaller SoC or an ASIC. And we are actually even enabling that in our future. So fundamentally, we believe that you should be able to select the right architecture for the right workload. And even within a workflow, you should be able to do that without worrying about having homogeneity across the board.
You mentioned that workload as a service, which is something that is core to your offering and the framing that you're presenting as far as the overall capability. And I'm wondering if you can dig into that abstraction and how that simplifies some of the approach of going from I have an idea to I have deployed an operating system, that the workload as a service helps in accelerating that path to deployment and reduces some of these infrastructure concerns and the variance and rapid evolution of the ecosystem that we've been discussing.
Absolutely. Yes. Look, we are evolving from platform as a service to GPU as a service. The last couple of years, this was the buzzword, GPU as a service. What it was plain and simple renting GPUs that only you have access to. You start renting a GPU, you have to now go build a stack on top of it to make sure that it can run, whether you're trying to run training on it, pre-training, fine-tuning, or you are trying to deploy an inference server on it. And everything will require a very different setup. Everything will require you to go get the right libraries, get the right dependencies sorted out. At the end, generally speaking, it used to take teams days to weeks to set up a new infrastructure, to start a new workload, and then tear it all down and then put a new configuration on it to then run new set of workloads. And that was massively time consuming. So while you need to do that to be able to actually build what you are building, so you can deploy some of your interesting ideas that you come up with, you are wasting a ton of time just setting it all up. So what we are trying to do with workload as a service is you worry about coming up with interesting ideas and deploying them, and we take care of the rest of it in the backend infrastructure management. So all you have to think about is what your idea is and what problems you're solving, and not worry about the maintenance and management and keeping track of all of the heterogeneous compute that might be actually useful or part of your workflow.
To your point of renting a GPU being the default method of gaining access to these compute accelerators, you then have to figure out, okay, either I find the smallest GPU I can get away with for my model, and then you have a very fixed ceiling in terms of what you're able to do, or you say, I don't know exactly what I'm going to do. I'm going to find the biggest GPU or cluster of GPUs that I can find, and then I have to figure out how I'm actually going to maximize usage of it, where maybe I have a fleet of LLMs that I'm serving for a chat-based application, or maybe I'm building an agentic compute system, or maybe I say, forget about renting GPUs. That's too much upfront capital. I'm just going to go the API approach and use a metered inference endpoint, and that has its own unpredictability and cost, potentially even more so. At least with a GPU, you know what the per hour rate is, and you can understand that, but maybe you're not going to have the flexibility to manage the capacity that you actually need. And I'm wondering if you can talk to some of the ways that you've developed your platform and your architecture to be able to help smooth over some of those load patterns and get the sort of economies of scale, as well as some of the ways that the unpredictability of these AI workloads complicates the work that you're doing to be able to manage that overall compute infrastructure and smooth out those load patterns across the fleet of GPUs that you are providing.
Again, really good question. And Tobias, we see this topic come up in a lot more customer conversations these days than actual access to compute. A lot of people are able to get compute these days, but their cost is becoming a real sore point. Recently, one of the favorite companies, Lovable, apparently showed up with $100 million ARR, but the cost of delivering that $100 million was almost $87 million or something like that. Like, it is just gigantic compared to what they're actually able to make out of these GPUs. So we definitely are building an architecture that allows people to smoothen their peaks and balance it with a little more averaged overall capacity required. However, we also have this ability to give you more compute for lower cost when there is less demand. So it's almost like, think about how Uber would do, price surge pricing based on what the demand is. But if you go middle of the night, there are no drivers, you just have to pay high. If you go, peak hours where there's too much demand, even though there are drivers, you pay higher prices. And then there are the average times. For companies that are trying to get a sort of an SLA for their customers, they end up choosing the highest level that they will ever expect to hit, which means most of the time they're sitting with idle infrastructure, and that's a huge cost. For companies that are trying to optimize for cost, they run into quality of service issues. At the peak hours, your responses for your chatbot or your queries is going to be hitting super high latencies. What we provide is a combination of access across multiple clouds and multiple architectures. So let's just take a case of enterprise who's trying to serve, a chatbot or, support system using some model. And they see these variations in their usage and their throughput, and they put some compute capacity on-prem because that's a little more in control and they control the cost, but it is below the peak that they can actually hit. So what we do is, if we bring their compute under our platform, we also connect a whole bunch of capacity outside of their infrastructure that is now available to them instantly. So the moment they get out of their own capacity, we have agreements with cloud providers, neoclouds, that we can take their capacity and start running the workload from the customer. And there is a small delta between what the cost is going to be because it's an on-demand capacity, but it's still lower than that company putting capacity that was actually going to meet that peak. On the other hand, somebody puts a capacity that is significantly higher than what they need normally. What we then do is we actually orchestrate various workloads using multi-tenancy and shared GPU concepts such that more than one customer, more than one user can use the same infrastructure at the same time. And that's another thing that, CPUs have been doing this for a while, right? I mean, multiple virtual machines can run on a single machine until you run out of capacity. Then you auto-scale a new node, a new server. GPUs weren't doing that. And we just started enabling that in our platform, where you can run side by side a training workload and an inference workload on the same infrastructure. So given where the demand is from inference, the training can actually auto scale to a different size if there is, a QoS there that allows it to be downgraded a bit, right? If you're doing, fine tuning and you were letting it run for a few days or a week or so, slowing down during peak hours is not going to kill it. It's not going to affect your business too much. And that's a beautiful way of actually maximizing utilization of your existing capacity. So these are things that we are actually enabling right now. On the other hand, there's this last thing that we are adding, which is actually very exciting for us, which is we were able to put capacity, let's say an on-prem capacity on NVIDIA GPUs, but there is inference that we can then launch on a different architecture. When you run out of your own capacity, we can just move that to a different architecture and scale it over there while minimizing your cost. These are things that were not possible before, but with our platform, we just seamlessly connect the user, the customer, and their workload scaling to multiple clouds, multiple architecture at any location.
That speaks to the overall requirement for effective orchestration in any AI application, whether it's just being able to orchestrate the deployment of the model to the GPU or being able to optimize for cost because maybe the workload isn't interactive and user facing, it's a more long running agentic workflow. And so you can schedule the execution of that agent to those cheaper times, lower traffic times. And curious if you can talk to some of the ways that your workload as a service architecture is incorporating these orchestration concepts to be able to effectively manage the load distribution and identify workloads that are time sensitive or interactive required versus the ones that can be more asynchronous or are long running and able to take advantage of these distributions of load.
Yeah, absolutely. And the concept is not new, Tobias. If you have studied computer architecture, you know there is a whole concept of scheduling, that the entire purpose there is to make sure every cycle of the CPU is busy. Why is that? Because that's the most expensive resource you have in the system. So your entire job in scheduling is to make sure every cycle is being used and used for the right purposes. But there's always a priority in there. The number one priority is based on the actual sequence in the queue, right? You pick the first one first. However, there are priorities attached to interrupts and high priority tasks, real-time tasks that get picked out of the queue and executed much faster ahead of something else. So we apply a very similar concept in our workload orchestration, and we let our customers define their priorities for various workloads. So they can say this is real time, and that means no one can interrupt them, and it will actually get ahead of the queue as long as there is no other real time thing ahead of themselves. They can set the priority to be give me the best effort. Best effort means I will find the cheapest and the most inexpensive resource and put it in the queue behind everything else. It will run when every other real time and high priority task is completed. There are some that actually are not real time, but they still have a priority on them because it affects the business objectives. For example, if you have a training that runs in one day, and if it ran over 2 days, you might actually have business losses. So in those cases, they don't get preempted, but they actually are getting similar priorities as real time, except the real time will always trump anything else because that is the priority zero. Then there's priority one, then there's priority two. Depending on what the business objectives are, you can continue to set those things up there. Now here's an interesting thing that we discovered and then implemented recently. As most training jobs go, there's always a checkpoint happening. And when we were checkpointing, we also got an opportunity to move that workload on the side if there is something else to preempt it. Interestingly, the cost of checkpointing has significantly gone down in the last 1 year. So now we do it seamlessly without waiting, without pausing the workload. It happens in the background, pretty much zero cost to the workload. Every checkpoint, we get an opportunity to see if there's a need to preempt it, go get a more high priority real time workload executed, get out of the way, and then go back and start running the same workload that is a long running workload that we previously checkpointed. So these things are actually now becoming very effective in maximizing the utilization of the existing infrastructure and resources we have access to. And that's something that I'm actually seeing a lot of people actually talking about. Oh, we used to have 20-30% utilization, to now we are pushing our utilization to almost 70-80%, which is pretty good. One anecdote on this is recently, a few weeks ago, we had, I call this the magical point, which was a proof of all of the things that we have been talking about. We had multiple customers on our platform. We had multiple compute clusters from various providers on our platform. And we have multiple workloads on our platform. And all of that distributed amongst all these different GPUs, consuming 100% of it. Everybody happily moving forward, and everybody combined using 100% of the compute capacity available. That was beautiful. I posted this picture on LinkedIn just because I was so happy about it.
And as you have been developing and iterating on this platform and the workload abstraction and onboarding customers, what are some of the ways that the overall scope and implementation of your system have evolved from when you first started thinking about it and building the initial versions?
Yeah, really good question. I think when we started on this journey, towards the beginning of 2024, large language models were still being built. There were many, many models being built at that time, but the pace has slowed down, and I'm going to expect a bit of consolidation as we move forward. The size of the models is growing pretty rapidly, so there are going to be people who just fall out and not be in the race anymore. But what is happening because of that is the efficiency for large language model training is constantly improving because now it's consolidated in one or two places, or maybe five companies working on very large language models, but they all spend enormous amount of time optimizing infrastructure, the model architecture, the data flow, failures. Everything is actually now under scrutiny, and everybody is looking for even the 0.5% improvement in utilization and speed. We didn't have that when we started. So early 24, we were still seeing 20-30% utilization of very, very expensive resources. I'm already starting to see, even outside of Flex AI, some improvements on that utilization factor. However, when we started, we were thinking training is actually going to be a lot more ubiquitous thing than what it ended up being. So we didn't really spend a lot of time on inference and model serving. But as we spend time with our customers, we realize that model serving and inference is actually running through the same inefficiency. As we were talking about, people either book capacity to hit the peak, and then they sit idle on that, or they're struggling with the response times during peak hours. And we realized that this concept of capacity versus utilization is very similar for even inference. And that's one of the things that we have evolved from the time we started to now. We now pay a lot more attention to smaller workloads, but the spikiness is pretty high. And we divide the workloads in a way and run the agents in a way that it auto scales to make sure that we are maximizing the utilization of the capacity that we have. There's something else that we also realized, which is the focus on multiple architectures wasn't there when it was just the training that people cared about. When they were all building models, they all raised millions and millions, billions and billions of dollars, and just focused on NVIDIA. But as they are moving towards inference, we are seeing a lot more opportunities of offering heterogeneous compute. And now it's not just about offering an API on a Grok or a Cerberus, but and again, if you stay in that paradigm, then you deal with all sorts of complexities with the actual platform. You will be on one architecture for training, then you move somewhere else, then you move somewhere else. For Flex AI, we just remain consistent with the platform. So your data doesn't have to be copied over. You don't have to move anywhere to a different platform. Your experience remains the same. You start on one architecture, you end on another, but you feel that experience is one platform. And that's actually one of the advantages that we are bringing, which is one platform, multiple workloads, multiple clouds, multiple location, tailored and optimized for your needs.
And so, for people who are onboarding onto the Flex AI platform, I'm curious if you can talk to some of the interfaces and abstractions and workflow that they should be aware of, and just the overall process of using Flex AI for going from I have an idea that I want to experiment with to I am now serving this at production load in an autoscaled capacity.
Absolutely. The first thing is, my initial thought was it should be as simple as, 1 click to 2 clicks, right? Make it a user interface, a GUI that is super clean, and anyone, even without an AI or ML background or infrastructure understanding, can come in and deploy something. Obviously, we work with a very technical group of people, so a lot of them actually already have workflows and they run their own containers, their own virtual machines. We enable them through a CLI, a command line interface. So we allow people to launch their workloads, whether it's training, fine tuning, or inference, using a simple command line for any of the models you can pick from the open source world. Point the platform to your data, and we take care of the rest. None of that setting up the infrastructure, defining how to set up the networking, and defining where to set up the storage and S3 buckets. But we also simplified things for people who do not have that level of experience or have built AI applications before. We actually started something called Blueprints recently, where if you're interested in building something like a smart search, voice transcription, multi-cloud migration, media image playground, we just enable that by giving people a blueprint of how to build these things. So we pick some standard models, open source models from Hugging Face. We have some dummy data or some reference data that we have used from open source world, and we build some of these applications for them to use for their own use case. So now they can pick a different model instead of the models that we picked. They can bring their own data, which they can use for fine tuning on or RAG. And then depending on what their applications is, they can actually have multimodal input and output. And all of that is driven by a single platform where these blueprints are already available. You can just go in and click and change some things and get exactly what you wanted.
One of the perennial challenges for anybody who wants to build a platform as a service and provide a unified experience for their customers is that there are always going to be some edge cases or some assumptions baked into the platform that are contrary to the assumptions of the team who are building the solution. And so finding the appropriate abstractions and interfaces, as well as providing escape hatches for those edge cases, is a path towards success. And I'm wondering if you can just talk to some of the ways that you're thinking about addressing those affordances and escape hatches and the aspects of the overall AI deployment and development ecosystem that you're explicitly leaving out of scope in order to be able to focus on your core competency of infrastructure abstraction.
Absolutely, Tobias. That's a great question, and we realized that very early on that the world is not going to be homogeneous, even from a philosophy perspective. Every customer that we talked to initially had a very different view on what their workflow would be, and we had to make some decisions because you can't serve infinite number of combinations and permutations. So we had to make some choices. We did make some choices, and the objective was that we serve a pretty large majority of the market. And one segment that we explicitly said we cannot or we shouldn't be targeting is someone who was already deeply expert in infrastructure management, and they were just about turning to become model people and trying to build some models, but their background and history was infrastructure management. The amount of custom code and micro optimizations they put in their flows is just impossible to manage and support, because these are sometimes their proprietary flows, and we don't want to get in the middle of their business. Having said that, we have now dealt with about 50-60 high quality users who all are looking to build models, train, fine tune, build multimodal outputs. And we can very proudly say that we now serve most of them, and we have roadmaps to serve the remaining ones with some of the new features that we are going to add. So you talked about edge cases. We said there is going to be a catch-all solution, and that's going to be containers. So our solution is, you want to run fine-tuning or training or inference, there is a very simple CLI, there is a very simple GUI web interface that you can go launch things with, and that should cover 90% of the world. But the other 10%, if they have some custom flows that we maybe, if it becomes important enough, we might actually make it part of our platform managed services offering. But for now, we can either help you package it in a container, and then now that becomes the workload. The container becomes a workload on our platform, and it asks for the resources it needs. It basically runs in the right priority order and then gets out of the queue when it's done. But that means that anybody who's not fitting in the way we run our platform or provide this service, they can bring their own containers and make it part of our scheduling system. It still can leave gaps and holes, and we are claiming that we are going to leave that 0.1% of the market, because that's probably out of scope for us for now. I believe pretty much every platform has to make a choice like that, and no one can guarantee 100% coverage, and that's the choice we are making.
And in your experience of building Flex AI, getting it in front of customers, helping them use it to its fullest effect, what are some of the most interesting or innovative or unexpected ways that you've seen the platform applied?
Yeah. So there were many learnings. One of them was one of our customers was trying to actually get their model trained and get ready for a YC demo. And they were struggling to just get their infrastructure up and running and get the training going. They somehow heard about us and they reached out to us, and we got them up and running within a couple of hours. And they were able to actually set this up and go do their demos. There were a couple of other examples where we didn't realize that we can actually solve a specific customer's issue by, this is an example where somebody had a ton of data, one of the hyperscalers, and they were looking for compute in a cheaper location with a new cloud. And we all were connected to the same people, and I knew where the pricing was going to be. It was like $1.50 compared to $6 on a hyperscaler. So the math was obvious. But the data movement meant that every time they had to pay the egress fees, which was like adding up to tens of thousands of dollars. The amount of data was large. Our architecture, even though we were designing it not for this case, our architecture allowed them to save the egress fees for any iterations. The first time we put this in a cache, and the caching was done between a cloud storage and on node storage. But once the first step was done, there was no more egress fees. And that saved a ton of money for them. And they were like, we would actually go with this solution because now we have access to all the compute in the world that is the right size, that is the right price, and that is the right capacity for us. And we don't have to worry about data movement or egress fees. There are many other examples that I'm definitely forgetting, but it just makes me happy to see some of the customers' use cases getting solved by the right thinking on our platform and the right solutions that we are building. And this is the reason why we started the company, which is pick a good problem to solve and solve it in a reasonable way, in a fast way.
And in your experience of building the business, investing in the technology and the abstractions and building the business around it, what are some of the most interesting or unexpected or challenging lessons that you've learned personally?
Interesting is when we first thought, I talked about this a little bit, when we first thought that we should build a managed service platform where, we can, reduce the number of permutation combination people deal with in terms of doing training or fine tuning. It was very clear that even if we were right, world was actually going to be a pretty fragmented world in terms of how many things people do, how people run their workflows and training. So we had to actually adapt very quickly on supporting more than what we were initially planning to support because it was more important for us to meet the customers where they were rather than the idea that we had initially. That was a pretty big learning for us, and that happened very quickly. And I'm really glad that we were working with some of the best developers and users who were very friendly and gave us support and helped us guide and nudge us in the right direction. That was very helpful. The second thing was, as we started deploying our first iteration of the product, we realized that people are not really excited about switching platforms. They don't like being on AWS for one thing, on GCP for another thing, and neo clouds and other small cloud providers for some other stuff, even if there is a cost advantage. And it is basically our concept too, which is, everybody needs a different setup and nobody really has the patience or time to set up all these different environments and manage multi-cloud and multi-provider. So that translated for us as we cannot offer just one piece of the equation of their workflows and say, use it, this is the best you can get, and then have them go somewhere else to finish their task. It needed to be an end-to-end workflow support. And that's something that we are actually now enabling and getting tons of good feedback on it. So you don't have to get out of our platform as long as you're not developing some of the largest models in the world. For example, XAI, you are our prime target. If you develop models, if you fine tune models, if you deploy agents, or if you have endpoints that you're deploying, everything is served in just one unified platform.
And you mentioned that on the high end, there's a certain level of scale at which it might not make sense to use Flex AI. I'm curious if there was a corresponding cohort on the other side of the spectrum where maybe there's a point at which you're too small for Flex AI to be beneficial. I'm just wondering if you can talk to some of the ways that you think about sort of your ideal customer and give some guidance for people who are evaluating Flex AI for their own use cases.
Actually, that the other end is zero. We are so supportive of small developers and startups that we have no minimum required on our platform. We offer on-demand pricing, we offer credits, we offer ways to minimize your cost. So if you're looking for one GPU equivalent compute or even fractional GPU equivalent compute, because we now support fractional GPUs on our platform, this is the right platform for you. So yes, let's say beyond 10,000 GPUs, you probably shouldn't be using a platform because you'd be trying to get every single ounce of this, very expensive cluster. and running a managed service on the top of that is probably not the best use of the resources. And when you are at that capacity, you're probably also focused on a single workload. You're not doing multiple things simultaneously, because when people build models, they just build models for months. So below that, I will say Flex AI covers everything under the sky. Once you get on the platform, you don't have to leave it, whether it's building it, optimizing it, tuning it, or deploying it.
And as you continue to build and iterate on the Flex AI platform, what are some of the things you have planned for the near to medium term, or any particular projects or problem areas you're excited to explore?
Absolutely. Some of the things that we are very excited about is bringing new architectures on the platform. So, we are working with TPUs, we are working with AMD, we're working with Tenstorrent. We will continue to work with more, silicon providers. One of the exciting things that we are testing right now in our internal development is inference autoscaler. So we have a tool that we have developed that is a simulator for the size or the capacity of the cluster needed for a specific throughput required for a given model. We're now applying that to start auto-scaling the capacity for a given user or a given workload. And that's going to be the most cost optimized solution for people who have spiky workloads or spiky inference needs. It's going to deploy new nodes and new GPUs within seconds of seeing extra traffic or higher traffic come through. As we were talking about before, I'm also very excited about deploying some blueprints. The ability to actually translate your vision and idea into a real product. I'm super impressed by Lovable. You have an idea for an app or a website. I'm able to now implement that in less than an hour or a day. That's exactly what I want to do with AI applications. You have an idea or a concept, you come on our platform, and you should be able to just use our widgets and platform and just deploy it within hours or a day. That's actually very, very, very exciting. Now, all of that can be summarized into one thing. I would like my fellow startup founders to focus on what they started the company for and leave the DevOps and the infrastructure management to us, so they can get the most value out of their teams and the money they raised. We can help them with providing a seamless interface to a clean infrastructure.
Are there any other aspects of the work that you're doing at Flex AI, or the overall complexities and points of friction related to the infrastructure for training and inference that we didn't discuss yet that you'd like to cover before we close out the show?
I think we covered pretty much everything. My summary of what we are doing is I want to make sure that people who are starting to develop new applications, come up with new ideas on using AI to solve some real world problems, actually focus on that and let us take care of the back end of it, the infrastructure side of it. The customers are recognizing our value. They are already using our platform and saving time. In my mind, the success metric for us is going to be when our users can claim that we haven't dealt with infrastructure issues in the last so many months that we have been working with FlexAI. And that's going to be a success for us.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gaps in the tooling, technology, or human training that's available for AI systems today.
I think this is a complex question with a very simple answer. My take is, if you are not using Flex AI, then you're actually building a team of very smart DevOps people, very smart DevOps engineers. And if that was the purpose of starting your business, starting your company, then you're doing the right thing. However, if you want to focus on the workloads and the problems that you're really solving, then your answer is going to be Flex AI. And the long answer of that is, every single setup, every single infrastructure setup requires a very different set of expertise, knowledge, and pain point resolution. A lot of people deal with just setting up the infrastructure, maintaining it, keeping it up to date, right? I mean, just which version of PyTorch and which version of CUDA should I actually use for this application? What is the model optimized for versus what is the quantization level that I have to serve? Those are two different problems. If you're focused on quantization, just focus on that instead of dealing with which PyTorch version we should be dealing with. And that's actually lacking in the industry. Most people actually are learning on the job. And we just want to stop doing that. We want people to spend time on developing their applications and let us take care of the infrastructure piece.
All right. Well, thank you very much for taking the time today to join me and share the work that you and your team are doing on Flex AI and giving some insights into the complexities of dealing with hardware and optimization of throughput for managing these AI applications. I appreciate all the time and energy that you folks are putting into making that a solved problem for the rest of us, and I hope you enjoy the rest of your day.
You do the best. Thank you.
Thank you for listening. Don't forget to check out our other shows. The Data Engineering Podcast covers the latest on modern data management, and Podcast.init covers the Python language, its community, and the innovative ways it is being used. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at aiengineeringpodcast.com with your story.